The next topic is conditional probability. Conditional probability is a probability of an event given some other event has already occurred. So we know for a fact that the other event has occurred. So for example, you draw a card from a deck of 52 cards, and suppose if you know, okay, the person who is looking at the card says that it is a 7. Okay, so we know that the card is 7. Now what is the probability that it is a heart? Okay. So what is the probability that it is 7 of hearts? So what is the probability of 7 of hearts given the card is heart, right? So that would be a conditional probability. So you can think of conditional probabilities in this fashion. So suppose if we know that B has occurred. So what happens is, this originally this is the sample space, and we have event A and event B. Now if event B has already occurred, so that means the sample space is now shrunk to just that circle. Okay, all of that outside the B, okay, they are not true. So sample space is now shrunk to just that circle. Now if you want the probability of A, given that the sample space is just that, then A is true only in this part of the new shrunken sample space. Now that part is A intersection B. So probability of A given B therefore is probability of A intersection B, okay, that divided by this. What is the proportion of this area relative to the entire area of B? So conditional probability then is P of A and B, the intersection, divided by the probability of the conditional event. Once we have that, then we can rewrite this conditional probability formula in this fashion. We can write, okay, so that is that formula. Probability of A given B is probability of A and B divided by probability of B. So which means probability of A and B is probability of A given B times B. So this is the a second way of writing the same formula, the intersection probability. So this gives you a formula for the intersection probability. Like we have the union law, so this is also called addition rule of probability. So here we have a formula for the intersection. And obviously this can also be written in this fashion. So probability of B given A then is probability of A and B. So A is given now. So the intersection of A and B divided by probability of A will be probability of B given A. And if you come from this direction, then the probability of the intersection can be written in a slightly different way as well. So that will be probability of B given A times probability of A. So both versions of the formula is true. Okay, so that's true and that's true as well. Okay, let's look at an example now. So we have say event A is draw a card 7. Event A is draw 7. Event B is draw a heart. Now what is the probability of A given B? Given that it is a heart, what is the probability that it is a 7? Okay, so given it is heart, there are 13 hearts in the deck, right? So 13, and of those 13 heart cards, there is only one 7. So 1 over 13 should be the answer, right? So we can do that by applying the formula to probability of A and B. So that is A intersection B, which we have from here, intersection B, A and B. Okay, so divided by probability of B. Probability of B is right here. Okay. Now that should be equal to 1 over 13. You see that it is. So this is the rule. Probability of A given B is probability of the intersection divided by the probability of B. Similarly, probability of B given, if you want it the other way around, can we start from the same place? Probability of A and B, okay, so divided by probability of A. So this will be what? Now you're saying that given A, it is a 7, right? Given that it is a 7, what is the probability that it is a heart as well? So here, there are 4 possibilities. There are 4 sevens. So there is only 1 heart, 7 of hearts. So now the shrunken sample space has 4 outcomes, and 7 is one of them. 7 of heart. The shrunken sample space has 4 outcomes, and there is one of them is heart. The others are not. So 1 over 4 should be 0.5, and you see that that's what it is. So when you divide probability of A and B divided by probability of A, you get 0.25.